I grew up in Brittany, in Concarneau, on the coast, on the sea coast, and that's how I decided to become a merchant navy officer. So I sailed all around the world on big container ships, tankers, cruise ships, all these big boats, and I've noticed something. Every time I was calling at a port and having a run in the cities, I could see plastic everywhere, in Africa, in South America. And obviously, all these plastics were not only just lying on the floor, but they were also ending up on the beaches and eventually in the ocean. So you've heard all the problem that this plastic in the ocean can cause. So I'm not going to last a long time on that. But yeah, every minute is the equivalent of 3 elephants, so about 18 tons of plastic ended up in the ocean. 3 elephants, which strokes me in a way when I realized that. So obviously you might have seen this impact, so birds and turtles eating these plastics and then eventually dying. But what we don't know really is these plastics, once in the ocean, it's too late. We often speak about the great ocean garbage patch in the Pacific Ocean, what we call in French a continent of plastic. And this is absolutely not a continent. This is not an island where you can just walk on this and easily to pick up. So this is not like that. This is microparticles, impossible to collect. So that's the key issue. And actually, there is only 1% of the plastic floating on the sea surface. So 99% of the plastic that is in the ocean is whether on the seabed or in form of microparticles everywhere in the ocean. So there's only 1%. There's no point in focusing on picking up this in the Great Pacific Basin. So that's what we realized first when we had some researches on that topic. So where does this plastic comes from? Well, 90% of the plastic entering the ocean comes from Africa, South America, and mainly Asia. So that's where we need to act. That's the 3 continents if we want to stop the plastic from the roots, avoiding it entering the ocean. So let me tell you, I'm going to continue the story. I was sailing all over the world on the big ships and smaller ones. And one day I was in Dakar. I saw we were calling at one of the most polluting parts of the city. There was plastic everywhere. And at the same time, somebody came to me and to ask me if he could make something for us, to try to make a living, like giving water or fuel. He was trying to survive. He was trying to make a living, like having small jobs. And I thought, well, that's stupid because all this plastic here on the beaches and in the ocean is a precious material available for free. So why don't we allow people to make a living from this plastic so that it's not thrown away, but rather collected and transformed, and people can make a living from that. So that's the starting point of the adventure. What we realized after some researches is that this plastic, this precious material, once in the nature, you can still pick it up and you can make, for example, houses like that, bricks to build houses, which is quite impressive, but that's not the most impressive one. You can also make pavements or roads made of this plastic, or different objects of everyday life, like furniture or so on. But the most impressive stuff I realized is that the unrecyclable plastic, so the majority of the plastic that is too polluted or not sorted, you cannot make any object anymore, you can still convert it into fuel. With 1 kilo of plastic, of non-recyclable plastic, you can make up to 1 liter of fuel. Exactly the same we have in our cars, so diesel and gasoline. So instead of extracting oil in some countries, you can use the oil that is here and polluting the ocean in forms of this material. So that's the other stuff we realized. So the process is it's very simple actually. It's like alcoholic transformation. You take plastic, you heat it up, and then the molecule breaks down so it doesn't burn because you put it without oxygen. And these vapors, you condense it, and you obtain diesel and gasoline. So it's a quite simple process. But the problem is, with all these technologies, beginning with the bricks for houses or the diesel, so the pyrolysis system, they all reserve to industrials, like big technologies, very hard to, very expensive, very hard to build, to repair, to use. And also, they are not known. I mean, even here, every time I speak to somebody, even an engineer, about this pyrolysis system, how to turn plastic into fuel, nobody knows that. So we realized there is something to do to make all these technologies accessible for everybody. And the key points of that is to build solutions that are small scales, because to solve this big problem, one possibility is to have several small factories instead of big ones, especially in Africa or in South America, Asia. It's much more, I mean, it's much better that to have small-scale technologies. The second one is open source. That means free of patents, so that everyone can take the drawings, the blueprints, and whether build his own factory or repair it easily. And the third one is low-tech. So we get rid of all these sensors, useless pieces that could break down, and we facilitate that by doing something very simple, very resistance, and that's the three key points. So we realized that for that, we could we can come up with three different technologies. The first one is to sort plastic, because once you pick up all these materials, you need to find a way to sort them, to analyze the plastic and say, okay, this we can recycle, this we cannot recycle. So that's the first one. This is only available, I think it costs like 20,000 euros for a small portable device to analyze plastics. So if you want a full-scale factory to sort plastic, it's even worse. So we started to work on this portable device to analyze plastics, to sort them. And the second part is a very simple technology to recycle plastic into new materials. So you can make whether plates or bricks or anything, but with the same machines. And the third one is the plastic to fuel unit. So when plastics are not recyclable anymore, we put that in this machine. And we thought, okay, we need to come up with these machines that are open source, but how can we spread them? How can we how can we show people that they exist and to build the community around to use and build that? So we get inspired by Solar Impulse that did approximately the same with solar panels, solar energies. They said, okay, we're going to make the first round-the-world tour on a plane powered by solar energy, proving that this is worth using it, and everyone can do that. We thought we need to do the same with all these recycling solutions. So the plan is to make the first round-the-world expedition on a boat that will use only trashes collected at each port and stored on board to be recycled into fuel and power the ship. So the ship will be powered only by trash. So that's the key of the project. But also it will be a recycling lab with all these other technologies to show what we can do with plastic. So the plan is to go around the world on these three continents. So first Africa, then South America, and finally Asia. During a 3 years expedition with 33 major calls, where we would stay for 3 weeks, 3 to 4 weeks, and other 30 small calls just to pick up enough plastic to make it possible to get to the other one. Here is a drawing of the ship. So you can see at the back of the ship 2 containers, one containing the plastic to fuel unit, and the other one for the storage of all the trashes we're going to collect. And in the middle of the boat, there is a recycling lab. So at sea, it serves as a living place for the crew. And once we stop, once we call in a port, we transform this place into a recycling lab to show what we can do with all these trashes, all this precious plastic material. The goal of this project is, first of all, to demonstrate all these solutions, but not only because we think that we cannot design a technology for Africa or for Asia if we are not in Asia or in Africa. We're not going to start designing all this technology here in France because we don't know what the people needs in Africa. So the second part is to discover and to understand the culture and the needs in each country, specific needs to adapt these technologies. For example, this is the best example I know. She's called Lorna Otto, and she lives in Kenya. She realized that all the signposts were made in metal and were stolen to be sold as metal material. And at the same time, she realized that there was plastic everywhere. So she thinks, okay, we're going to take this plastic and we're going to make signposts out of that. So that, first of all, we recycle plastic, and second of all, they are not stolen anymore. But that's exactly the kind of problem, of needs locally, that we cannot think about in France or in Europe, America. And this is real needs. So that's the second objective, the second goal of the expedition. And of course, the third one is to spread the technologies that will be developed and adapted to the people's needs to everyone, creating human-scale businesses out of recycling machines. So here's the timeline. What we're doing now, we are building a first prototype of a boat which will be 6 meters long and will be the first boat to be powered by plastic. So a 6 meter long boat, which is currently built in Michel Desjoyaux's shipyard in Brittany. And after that, so that's the key point of the project, to demonstrate that it is actually possible to power a boat out of these trashes. And after that, 2 years of preparation to sail in 2020 for 3 years of expedition. And we will be in this event as well. I think that will be the first time that the boat will be shown to public, this International Clean Tech Week, which is also in the same mood that ChangeNOW. I think the boat will be ready for this event. So we will be running in the lake in Annecy with our boat running from plastics collected. Okay, I'm really working for that. So thank you.